From today's title, this is the question we should answer today. We should know what is structure, right? And we should know what is a program and what is programming, right? So from our lesson title, I want us to answer these two questions. First, we are going to ask ourselves, how do these things relate to us? From what I can tell, we all have smartphones, right? So we are a digital class. In our sessions, as we learn structured programming, we are going to be using these devices a lot. Some of us already have laptops, then we have smartphones, and we have the internet. So we are going to be using those devices for references a lot. Because like now I want to use an analogy, using your device, or even using yourself. Yourself, you are a device. You are programmed by God, right? You have hardware and software components. Since most of us are high school leavers, we must have learned computer basics. We know that computers have hardware parts and software parts. This software is what we are dealing with, right? This software is the one that performs the functions that we want this device to operate. So, what is a program? A program is a set of instructions that perform a certain task. So I want us to brainstorm some of the tasks that our bodies as devices perform so that we can get into them and realize what programming involves. So we are going to start from the left. Dan, tell us some of the programs that your body performs. Walking. That is a program. You must have the software that instructs the legs to work, right? You must have a software that creates the program that you call walking. Thinking. That is a very complex software. That is what people are coming up with that we are calling AI and machine learning. People are trying to borrow the idea of God, the way He created you, that you can think, that you have intelligence. Now we are programming these machines with software that can think for itself. It's intelligence. Sleeping. Do any of the devices you create sleep? When you turn off your phone, unless it sleeps, right? So you can also call it a program. A program where the main functions, they rest. And the only thing that is running is what? The digestive system, the breathing, and the blood, and the other parts. So another program that our body has, digestion. Actually, if you studied biology, you should know that digestion is called an involuntary program in your body. It runs without you consciously telling it what to do, right? So using this analogy of our body, we can tell that these are the set of instructions that govern your body, the hardware parts of your body. They govern it on how to do it, right? Using another analogy, let's talk of a car, a vehicle, like the one I came in using today. Right? My Harrier XP.
Yes.
Right?
Yes.
So this vehicle of mine, it has the hardware part that you can see. The wheels, the axle, the engine, the oil, the steering wheel,
the body.
You can't see that? Oil.
How can you see?
If it spills, you'll see it. But I agree with you. It's like your blood. The only way you can see it is tell us. So now let's realize that this car of yours, for it to move, it must be instructed, right? And the way it moves is procedural, it's sequential. If you want this thing to move, you must have gone to a class and learned how to make this thing, right?
Yes.
So now that is where this thing we are calling structure comes in. It's planned, it's pre-planned. It is already organized on how you make this thing, right? Even God, when He created your body, He encoded your body with what we call DNA. That is where the code of your body is. It is the one that tells your body how to regenerate, how to make cells go where, and what cells do what. That is where it is programmed. So, by now you should be able to tell what a program is. A program is those set of instructions. So when we say programming, it is the action of coding those instructions into the device. But in our class, we are talking about computer programs. These programs, they are encoded into this device. Those instructions, they are encoded into the device. And for them to work, for them even to be encoded, they must be put there by a programmer. So these are some of the terminologies we're going to be using in our class. There is somebody called a programmer. Who can tell us another name we use to refer to a programmer? Anyone? Another name we use for a programmer?
User.
User, let's use this is another terminology, but we are looking for a word to use. If you are a programmer, if you are the one who, maybe God is the programmer of our bodies, right? What other name can you use to refer to God as the programmer?
Creator.
Creator, right? That is a loose word, but it fits, right? Another name? Developer, right? The developer. These are just names for people who do these things, people who are involved. Developer, right? Another name for this person? Any idea? Let me introduce to you another word. Let's use even this word that you're using. So, I want to introduce to you this name. You heard of this name? Right? This comes from the action that is coding. Right? So, a coder. Another name that people use is this one. Do you know what this means? Software engineer. So when you're done with this unit and you are a creator or a developer or a programmer, we'll call you a software engineer.
I have a question.
Yes?
Does content creator one programs?
Not necessarily, but if you're going to argue out in terms of TV programs, yes. But in our class, we are dealing with computer, right? So content creation is another whole field. In our case, we are dealing with computer programs. So from here, these are the terms that I would like us to be using to refer to a person who does what we are learning. We are going to be using these terms. You either become a programmer, or you call yourself a developer, or you call yourself a coder, or you call yourself a software engineer, right? So, what is structured programming? By now we have a hint of what we should cover in this lesson. Now we know what a program is and what programming is. So let's get into what we mean by structure. So we are going to look at structure and unstructured. We are going to have a brainstorming session where we are going to discuss what is structured and what is not structured. And we are going to use analogy of real life events and things that we come across. Right? Like now I can give us an example of something that is structured, like cooking. Right? For you to cook, you must have a structured way of cooking. You must know what comes first. You must have ingredients ahead of the others, right? That is what we are calling structured. We know what comes at what time and the amounts, right? If you are cooking ugali, you can't start by putting the flour first, right? You must start by boiling water and then adding the flour. You must be mindful of the temperature at all times.
Must make sure that you have a sufuria first.
You must have a sufuria first, right? So that is what we are calling structure. So what is this that is unstructured?
Something that does not follow specific single unit.
Who has an example of something that we know that is unstructured?
When you have chaos.
When you have chaos.
You run haphazardly.
We run haphazardly, right? An example of something that I can give us that is unstructured is an immature person, a kid, a child, right? They haven't consolidated ways of doing things already, right? If you ask them to cook that ugali and they've never done it, they will look around the kitchen. They just know what ugali looks like, right? They don't know how to get to that step. It's not ordered, right? But this one that is structured is like a mature person. They know what comes before the other, right? So this is why we are going to differentiate types of programming languages first. Before we even come to classifications that we're going to look after, we are going to get to classifications. So we are going to look at what structured programming is. So under this structured programming, you are going to classify it into several ways. The first thing that you can think of is that it is procedural. And then it is modular. And then it is sequential, right? That is to say it is procedural. But you are going to use that word. So, as part of our assignment, I want us to look at these three words. These terminologies, note them somewhere, and go and look into them and how they relate to being structured and programming that is structured. Right? Yes. So let's do a recap. We are going to do an activity called 2 truths, 1 lie. Right? So I'm going to give you statements and you're going to tell me which ones are true and which is the lie. Right? So, statement number 1. Structured programming is modularized. Statement number 2. A creator of a program is called a hardware engineer. Statement number 3. Programming is the process of analyzing, developing, and designing computer software. So, which are the 2 truths and which is the lie?
Number 1 and the last one are true. Number 2 is false. Number 2 was that a computer programmer is called a hardware engineer.
Hardware engineer.
Yes, false.
Right? Because we are dealing with
Coding.
We are dealing with
Software.
right?
Yes.
So, moving forward, I want us to get to this mindset that you, in this class, at the end of this unit, you should be able to be called a software engineer. That you should be able to engineer instructions that can instruct these machines of ours. Right?
Yes.
Have a blessed day.
Hello, this is Ronald Mwangi at kstvet and I'm training to become a computer studies trainer.